I'm Vijay Kumar, Dean of Penn Engineering. I'm honored to be invited to address women in data science and proud that my colleague Professor Susan Davidson is one of the co-organizers and that our school is a co-sponsor of the conference. The language of data science, to me, is the new lingua franca of all of science and technology, and of course all of engineering. And there's many reasons for that. First of all, an estimated 44 zettabytes, which is 44 trillion gigabytes of data, is being generated annually about the world around us. The cost of storage hardware has dropped dramatically. Indeed, if you compare the cost of today's hard drive capacity, it's less expensive than the hard drive that IBM first commercialized, the drive that I used, by more than a factor of 1,000,000. It's no surprise that these technological advances are indeed leading to a fundamentally different way to think about scientific discovery and technological innovation. Deep learning has taken an old 1960s idea, neural nets, and suddenly made it practical. In 2012, there were 2 high-profile deep learning projects. 4 years later, that number was around 1,000. Now, we don't track the number of deep learning projects. But in 2017, AlphaZero, a computer program developed by DeepMind using deep learning, showed superhuman performance in a wide range of difficult board games with less than 24 hours of training. And just last month, AlphaFold, also developed by DeepMind, was able to show how the 3D protein structure causes it to fold into a unique shape. In effect, AlphaFold solved the protein folding problem, which has been a grand challenge in biology for over 50 years. Yes, everybody refers to these advances as being enabled by AI. But let's not forget that training using large data sets is central to all of these methodologies. If you go back in history and explore the origins of scientific advances, I would say we've moved beyond, starting from the age of empirical paradigms employed by Galileo and Copernicus, to the analytical paradigms of Sir Isaac Newton, who invented calculus, and now the computational and data-driven paradigms that have become increasingly important. Indeed, you can do this thought experiment and ask, what would Sir Isaac Newton have done if he wanted to study what causes motion? Would he have invented the tools of calculus to describe the motion of an apple falling to the ground? Or would he have simply whipped out his iPhone and taken videos of apples falling to the ground and come up with a completely different way of describing gravity, an approach that simply relies on data? I jest, of course, when I say this, but my main point is that the tools that we use in data science are different, and they're becoming increasingly important in all aspects of science, engineering, and technology. Data science is particularly important at Penn. Penn is home to at least 5 top-ranked schools whose core intellectual agenda includes social science or applied social science. Can data science provide us with the tools to create computational social systems that facilitate civil discourse and debate, and to help us solve practical problems? Socially aware data science is emerging as an important area. Can we develop the framework for incorporating social norms like privacy and fairness into algorithmic design? Can we address questions of transparency and ethics? Well, Penn faculty are working on these problems in data science and more. And data science is allowing us, the School of Engineering and Applied Science, to build bridges with Wharton, SAS, Social Policy and Practice, Penn Law, and the Annenberg School of Communication. Penn is also the home to 4 top-ranked health schools. And today, fundamental advances in data sciences are enabling new techniques for aggregation of multi-scale clinical, biomedical, and contextual data about every patient, and decision support tools to facilitate optimized, patient-centered, evidence-based decisions. Our faculty are also addressing complex questions of data integrity, of provenance, security, privacy and reliability of data, and yet again data science is leading to bridges with the Perelman School of Medicine, Penn Dental, Penn Nursing, and Penn Vet. We are embarking on a new 120,000 square foot data science building at 34th and Chestnut. This building will be the home to data science at Penn. And this will allow our faculty and students to connect with faculty and students with similar interests across campus. Indeed, we've already started new educational programs in data science. Under Professor Davidson's leadership, we have a minor in data science for Penn undergraduates, a new master's program in data science. The new courses that we've developed over the last 5 years in data science, which includes databases, machine learning, and AI, are heavily subscribed, indeed oversubscribed. Professor Davidson, along with Professor Ives, the chair of computer science, co-teach a course on big data analytics, which enrolls nearly 400 students from a stunning 50 different majors. The Penn Compact is anchored in 3 words, all starting with the letter I. I'm sure you've heard it. Impact, innovation, and inclusion. I've just talked about innovation enabled by data science and the impact of the field. At Penn Engineering, we also take inclusion seriously. And there are 2 broad themes to our effort. First, we're lowering the barrier to entry to the fields of computer science and data science. We've developed several online courses, starting with Philadelphia area high school courses to MOOCs on computational thinking and networked life. Our online Master of Computer Information Technology program reduces the barrier to entry in computer science in 2 ways. First, we do not require a bachelor's in computer science. We teach students the relevant mathematical, computational, and programming skills needed for computer science. And when they graduate from this program, they get jobs that bona fide computer scientists do. Second, this degree is offered online at 1/3 the price of an on-campus degree program. Again, lowering the barrier to entry. And similarly, we're also planning a master's in data science that will also be fully online, allowing access to a bigger community, a community that doesn't necessarily have to be in Philadelphia. Professors Ives and Davidson have collaborated with IBM and the Linux Foundation to create educational materials for data science. So not only are we lowering the barrier to entry for students in data science, but we're also lowering the barrier to entry for teachers of data science. Their materials are called Open Data Science for All, and they're available open source for all teachers. The second broad theme of our effort is addressing diversity. Diversity is a grand challenge for engineering, especially gender diversity. There's an obvious challenge to diversity. What if you're trying to solve a big problem and only half the members of your team could help? This is the challenge with gender diversity. And this is the problem that the tech industry now recognizes. But to me, there's also a bigger problem. And this bigger problem was clearly articulated by the former president of the National Academy of Engineers, William Wolfe. He said that without diversity, we limit the set of life experiences that are applied. And as a result, we pay an opportunity cost. A cost in the products that we don't build, in designs that we don't adopt, in constraints that we don't fully understand, and in processes that we don't invent. At Penn Engineering, we've taken on this grand challenge. We've created a new position of Associate Dean of Diversity, Equity, and Inclusion. The office is directed by Professor C.J. Taylor, and his office has taken on several key initiatives towards recruitment and retention, improving our climate, the climate in our school, and educational outreach. These efforts include supporting our very successful Advancing Women in Engineering program. And by the way, the founding director of our program was none other than Dr. Davidson, the co-organizer of this event. I credit this program for recruiting a freshman class that has averaged around 40% women over the last 5 years, well above the national average for an engineering school. I'm also pleased to say that the field of data science at Penn has attracted more women to engineering and computer science than other fields. In the last 4 years of our offering the Masters of Data Science, 40% of the applicants have been women. In contrast, if you look at students graduating from the nation's colleges, engineering schools, less than 15% of the graduates of accredited computer science programs are women. Let me conclude by sharing one final thought. The biggest transformation that's occurred in the last 5 years in our society, one that's leading to a fundamental change in the process of discovery, research, and development, the process of technological innovation, and education. This transformation is a paradigm shift, and the paradigm shift is from first principles, model-based methods that have been developed over the last 3 centuries to data-driven methods, which are being enabled by low-cost, ubiquitous sensor technology, by affordable connectivity with high bandwidth, inexpensive storage, and novel statistical machine learning algorithms. This set of technologies has also enabled, in my mind, the second wave of artificial intelligence. And I'm personally proud that Penn is at the center of this second wave, and even prouder that women in data science are leading this wave. I want to congratulate the organizers for organizing this conference, and a big thanks to all our speakers and all the attendees. I wish you all a successful conference. Thank you.